Just sharing my screen now.
Okay, terrific.
All seems to be working. Yeah.
Yes, we
Okay.
can see it
Hi.
just.
Shall I start? Yeah. Yeah. Hi. So, hi everyone. I'm Cesare Ardito from the University of Manchester in the UK. I am joining you from the UK, so I really apologize that I'm going to leave after my talk ends because it's late evening here and I need to get home. But I will make sure to catch up with everyone else's thoughts. So apologies for it seems rude. I thought I would say a few words. So my talk is focused on AI detection as a whole. So these teams from this spring, well, we ran a focus group in our institution, and we had to decide what approach we should use short term to look at to tackle the big challenges posed by generative AI being widely available to students. And I was tasked with a certain analysis on generative AI detection and the status of the technology. And basically, these are the updated outcomes of the insights gained through that I thought I would share with everyone and with the wider world as they may be helpful. So first of all, why? Sorry. Oh, sorry. There seems to be something odd with slides. So yeah, sorry. I'm not sure what the first slide was. So generative AI being widely available for students is clearly something that poses some challenges and dangers. These are just some of them. So contract cheating, of course, students can just present work generated by AI as their own and get assessed on that and get marks. Plagiarism, of course, the usual paraphrasing tools through the large language models interface can become much more sophisticated. So students could plagiarize and then rephrase creatively without doing any work. Collusion, where the student is asked to perform a certain task and it makes AI do it. Very similar to contract cheating, but it may just be not full contract cheating, but it may be, again, collusion. Unreliability, where ideas that seem reliable and should have seen from critical analysis of something by a student are actually just random. So they may hallucinate or be simply false, as I'm sure you all know. And further, there are other challenges with privacy, IP concerns, bias propagation. As the first speaker reminded us today, AI tools are a reflection of our society because they're trained on text generated by humans. So they exhibit several biases that are common in society. So clearly something must be done. It's not a case of we can just ignore it. And the question that I was tasked to answer was, should detection play a role in the countermeasures? And as you may see by the title, my answer is basically no. So there are 4 types of things that I characterize as detection. Most of the talk will be about machine classifiers, but I thought I would start with human insights. Then we have watermarked models, and then we have what I call surveillance/fingerprinting. So again, most of the talk is about what you think about detector, so some machine that looks at text and tells you whether AI has written it or not. But let's start with human insight. So human insight is that you read text and you can just tell. So these are 3 examples found on the internet. So the third one is got to me. I received a reference letter which ended with regenerate response. So this is pretty clear-cut evidence. So this clearly AI was involved into the write-up of this text. So in that case, you have enough evidence. But in any other case, we've seen around that many people, especially at the start, began that they had thought that they had an insight into spotting AI written text. And so this is commonly known as the lazy user model, where I just give this example. These designs on Christmas cards, you probably have seen some of them very recently, about a month ago, because these are the top designs on Canva, which is by far the most used graphics interface tool currently available for Merry Christmas cards. So if you see these cards, it's clear that they've been created using Canva. However, most other cards you will see will also likely have been through Canva or to an equivalent graphics tool, but you won't be able to tell because the designers will have done something special with it, maybe use more advanced function or more obscure templates, or just made their own template. And similarly, if you talk if you ask ChatGPT to respond to a prompt of 5-6 words, then it's going to assume it's sort of standard persona, and that becomes recognizable both by humans and detectable. But as soon as the prompt is slightly more advanced, or maybe the model is not set to its default parameters, it's just shifted or changed or trained in a different way, then it becomes much harder to spot it, to the point that I've just selected 4 studies. I chose studies that are quite early because, of course, more advanced models like GPT-4 are harder to detect with human insight than early models. But even then, we're even just GPT-3. GPT-3 is pre-ChatGPT. In this study, they looked at text that just paragraphs on basically random topics written by GPT-3 or human, and they were unable to detect them. Again, in 2021, they went with poetry. They tried to make AI write some poems and then compare with human ones. And again, people couldn't differentiate these two at a statistically significant level. In 2022, self-presentations generated by AI in professional hospitality and dating contexts were unable to be distinguished by human ones. This was more in the context of a cover letter or CV or dating website profile. And the more recent one that I chose to highlight is one on abstracts. They made a conference abstract generated by ChatGPT, so it was on specialist topics. And here, blinded human reviewers performed slightly better. So they did manage to correctly identify 68% of the abstracts. But still, again, this was GPT 3.5, so we can expect that it's harder with GPT 0.4, and it's not very reliable at all to be applied in any academic context. So the 68% accuracy is not something you can use when you're deciding whether to accuse someone of malpractice or not, right? Especially given the high error rate. So in general, just be aware that, yeah, we may be able to detect very basic GPT, especially if you've used GPT a lot. Even I sometimes spot something that looks written by AI. But just be aware that it's very easy to tweak with it and move away from the default persona that we think is ChatGPT, and it just performs differently. A similar picture is actually what emerged in machine learning detectors. So by machine learning detector, I mean, or machine classifier, software that takes text as inputs and goes sentence by sentence and gives a probability that that sentence has been written by a large language model among the ones it's been trained on. There are many different approaches to how these things are built. So I don't want to get too technical because it's not really the scope of the talk. Some are built by, I would say, brute forcing, in that they're given a corpus of AI written text and a corpus of human written text and trained to differentiate with a basic reward model. Some are more sophisticated. They look at, for example, perplexity when they compare the likelihood that the words in the text match the probability distribution of the model when that is known. But honestly, the performance is fairly uniform across different approaches that have been built. Originally, there was a sort of, let's say, official one. By that, I mean an OpenAI text classifier that they've withdrawn 6 months ago because it wasn't performing well, and they just chose to not make it available anymore. And then there's Turnitin, and there's Zero GPT, and many others that are available on the internet. So the first vulnerability that emerged in several studies is basic attacks. Basic attacks, by basic attacks, I mean something that can easily be done or automated, even by a non-particularly sophisticated user. The first one is paraphrasing, of course. So there's a study from 2023, but also the second study cited here looks at paraphrasing, and they all agree that simply paraphrasing attacks, substituting certain words with others, lowers significantly the accuracy of detectors. So text that was correctly detected as AI generated is now incorrectly detected as fully human written, simply by paraphrasing. Prompting strategies, which can prompt the model into producing more otherwise unlikely words, Here's an example of a prompt that I've taken from this study, in which the model is told to include personal reflections, use a mix of sentences, and employ rhetorical questions, and this lowered accuracy significantly. Iteration through the same or different models. You can have a model write text and then change it based on feedback, or you can put it into another model and say to rewrite this in your own style. These, again, lower security. Again, all of these measures are moving away from the default incarnation of the model, which is the one that's actually detected. And finally, parameter tweaking. You can get GPT and tell it to be more creative, raising its temperature, whatever that means, and it will write text that is less likely to be written otherwise, which messes with the detection algorithm. So basic attacks are the first problem where it's actually incredibly hard to get a correct measure of accuracy, because when you're vulnerable to these many attacks, even setting up any data set is very, very hard, given the amplitude of text available and the fact that vulnerabilities can be discovered pretty fast. Nevertheless, the current incarnations of detectors do appear to be vulnerable to the following basic attacks, which is a concern for any integrity measure based on those. So again, an example I made, this was in an old detector. This prompt was correctly identified, but going through a simple paraphraser, GPT-1, which is freely available on the internet, lowered the likelihood from 94 to 6. So this was just to give an example of how much effort is involved into a basic attack. This was 30 seconds and some copy and paste. Another vulnerability, moving on in the approach of using detectors, is that the error rate of a detector, so not looking at the AI text which is missed, but the human text which is misidentified, is also a big concern. And it's an even bigger concern when we consider that this is not a fully random process, so error rates are likely to not be uniformly distributed. You've surely seen, if you're following the topic, a study that made the rounds in this summer, where no native English speakers were found to be massively more misdetected as AI generator. In again, this study from 2023. Turnitin actually published a defense against the study, where they claimed that this did not really happen with their detector, because the study was based on samples of text which were shorter than what they think is the smallest threshold of words. And as far as I know, this study has not been replicated yet. So I put a red question mark there. Regardless, it is true that non-native English speaker text is more predictable, is more scripted, it has lower perplexity. So it is plausible that this may happen, but we definitely need more evidence to see if specifically non-native English speakers are actually more vulnerable to misdetection. The full team of low perplexity samples is the one where commonly seen sentences or structures are mistakenly detected as AI generated because they show up in the training data exactly as they are. So an example being the US Constitution. Of course, when it's the US Constitution, you can just tell. It's like when if a plagiarism checker finds that the US Constitution is plagiarized, yeah, of course, but that's not a concern. But do remember that we don't know all the low perplexity samples, and AI is a black box. So the detector doesn't tell you why it thinks this is AI generated. It just gives you a number, which it claims is a probability. So unlike a plagiarism detector where we can just laugh, if we don't know the US Constitution, we may actually genuinely believe that's been written by AI, and we don't know all text with low perplexity. And indeed, this fits into the third point, in which the biases are unknown and can vary based on even small tweaks in the detection algorithm. And we know that detectors are reactive because models change all the time, so detectors have to change all the time. So it's actually very unlikely that we will ever have a detector which has strongly being independently evaluated and we know exactly what is pitfalls, because these things change so fast and it's so hard to evaluate the abilities of a detector on a meaningful sample of text, which actually manages to capture all possible basic attacks, that that I'm skeptical, but it's fair to be skeptical, I think, of the fact that we will ever have a detector which has been tested as truly as other tools we use have been tested. And finally, another concern is that with dataset pollution, where now a lot of the text we see around has been through AI. And so truly human written text is hard to come by. There are a few datasets before 2021, which are sort of the gold standard, but as human speech evolves, as it does, will be really hard to actually have purely human text, even just to train the detector. So this is a future-proof concern. Again, moving on, even assuming you have a detector, which today works very well, most vulnerabilities, if found, can be automated in a matter of minutes. There was a popular post on LinkedIn I saw where it apparently was common knowledge among students at some point that Anthropic's model, which is an AI model, was not vulnerable to detection. So all students went en masse to register on that model in order to be able to use it. There is a strong economic incentive, not just for contract cheating companies, but even for spam bots. If detection technology were used by Gmail's spam filter, you can imagine how much money there is in finding a way to get around that. So your email goes in the inbox. And further, there's early mathematical evidence from this paper, of course, that there can't be any such thing as a perfect detector, in that any detector will have a flaw, which can then be found and can spread. And again, there have been some cases in which this actually happened with ways to evade detection that went viral really fast, and so made the fortune of some small companies. So this is another concern for us. Even if we have a detector today which performs to a reasonable standard, if we decide to use it, we don't even know it's going to be valid tomorrow, regardless of, again, what the company does. So it's a shaky ground to be based on. And this is the biggest problem that I see with the future that emerge quite a lot. All detectors basically say we identify stuff that has been fully written by AI. If you write a paragraph and then ask AI to modify slightly, so that's co-created content, we are not trained to find that. But of course, misdetection is more possible to a co-created content than it is on a fully human written content. So compliant use of AI is more vulnerable to being misdetected. Again, this has been seen in a few exploratory studies. And what has been also seen is that some students, risk-averse students, avoid using AI even when they're told they should use it, because they fear that the approach by their institution will see them accused by malpractice. So if we, as we seem to think in the UK, we have the Russell Group universities, which have put out a very good statement, and I've seen similar things also across the pond, that we should teach students to use AI and tell them this is good usage. You can use it to generate ideas, to improve your prose. You can use it for grammar checking and so on. Then we should at least guarantee them that they won't be misdetected and accused of malpractice because they followed our instructions. And therefore, detection being as raw as it is, being unable to distinguish and making us unable to distinguish too, because detection doesn't tell us anything but a raw number, unlike a plagiarism checker, which gives us the original source, and then we can make an informed decision. Detection doesn't do that, and it won't ever do that, because you cannot reconstruct whether text has been written by a model or not, and with what prompt. So by doing this, we risk that everything that uses AI in a compliant and good way gets misdetected, which again makes the tools of dubious utility. Just bear in mind that many accessibility solutions already use generative AI. I'm talking translators, Be My Eyes for visually impaired people, and many others. I mean, this call is probably being transcribed by an AI transcriber right now as we speak, if the Zoom function has been turned on. So by what I said before, just to stress the point, is that I'm finishing now. I know I'm a few minutes late. Plagiarism detection and AI output detection are really different, because AI output detection is not falsifiable. It only tells you how much of the text may match a model and not anything more, and it cannot be independently evaluated and verified. So it's a misaligned tool, but we care about something, the tool tells us something else, and we need to bridge the gap, but there's no way to bridge the gap. So even a passive detector, which just tells us the information, but not, and then it's up to us to decide, may cause bias in the marker. Because if a detector tells me this has been written by AI, I may look at it with suspicion, and there may be no reason to look at that with suspicion because the detector may just be wrong. So what I'm saying is scrap the detector, especially since malpractice is not something that is taken lightly by institution, and rightfully so. We have very serious malpractice accusations. So a student which accused of that for no reason, as it has happened, these are just 3 random posts from social, but there's been newspaper articles, there's been lawsuits, can A, discourage good AI usage from students, which is bad if we want to teach them, and B, can cause significant waste of resources and even legal liability when the student is found to be accused of something and then somehow they can prove that they didn't do it. Again, there are further issues on privacy and data protection, where students copy and paste their work into dubious websites just to check. And again, that's a serious problem. And finally, just say word of God, both Ethan Malik and François Chollet, which are very active on the AI analysis side in education, sort of agree with the points we've made, where AI detectors really don't work, and it's not even unethical to delegate this decision to an algorithm, which it can have a very high error rate. So just a few words about the 2 other types of detection, as I promised. Watermarking will have a model which has an inbuilt way of remembering that the text has been by a model. This is a very trivial example. There are more sophisticated ones. It can be vulnerable to paraphrasing, but apparently that can be made not true. The problem for us is that there are already models which are not watermarked. So we cannot just say, oh, all AI text is watermarked, so we're fine, because it's not, and students would just use the other one. So watermarking is unfortunately cats out of the bag, as we say here. And fingerprinting has the idea that students work in a controlled environment. So they cannot use AI because we check step by step what's going on. And of course, this can have varied degree of efficiency. Keeping track of drafts is quite mild, or we can fingerprint the student's writing. So instead of detecting AI, we detect the student. Again, this has vulnerabilities because AI can emulate a student, or will soon be able to. And of course, usual problems with privacy, anxiety, accessibility, and mass surveillance apply. Think about what happened with the pandemic and all the Proctorio scandal, and all the problems we had with remote surveillance of exams and so on. So finally, final message. Currently, the detectors are unreliable, and it doesn't seem that this will change very soon. They are misaligned with respect to what you want to do. So I say they tackle the wrong problem, because as soon as we allow AI usage, malpractice does not equal AI. And in fact, we want to break this equation because we want students to engage with the new tech to have an advantage in the world of the future. And there are many people who want to sell you AI detection, because right now we're still panicking. That's true. A bit less than last year, but institutions still, I don't know what to do. So of course, it seems like a very, very easy solution, which unfortunately doesn't work. So I'd say hold the line. So thank you. Sorry for going slightly ahead of my allocated time. And yeah, if there are any questions in the chat, to take them.
Thank you, Cesare. If you just stop sharing your screen, and then we can see the chat if there are any questions. Thank you so much.
I think I've stopped sharing. Yeah.
You have.